So,
class on Thursday?
you are asking the wrong person. No, I think we have it on Friday.
Okay.
Yeah, I think Thursday is a day 3, and I think I don't see you on day 3. Okay, so we're looking at our page from our book, 196, this little bit I glued up there to the top. And we're looking at problem 6, and we're trying to figure out if that's a power function. And it is. Its degree is 5, and its constant of variation is 1/2 k. Are you with me? Everybody looking at what I'm looking at? Number 6. The variable is v, so the power is 5, or the degree is 5, and the constant is 1/2 k. Exactly the same in number 7. What's your power in number 7? 2. And what's your constant of variation? 1/2 g. 8. Same thing. What's your power? 3. And your constant of variation is 4/3 pi. 4/3 pi is the constant. 9 is a little bit trickier. In number 9, you have to recognize that a variable in the denominator has a negative power. So another way of writing number 9 is k times d to the negative second. Negative exponents put you in the bottom. So this guy has gone to the bottom, so when I bring him back up, he's -2. That's still a power function. Its power is -2, and its constant is k. This would be one of the reciprocal function looking things, because it has a negative exponent. Remember we talked about that? Do you remember those rules we talked about last time? Okay, everyone's just staring at me going like, I don't know. Number 10 is not a power function because m and a are both variables. M and a are both variables. If you look over in the directions, they tell you that c, g, k, and pi are constants. Anything else is a variable. So that's like having x times y, right? That is not a power function. That was a no. Okay, so let's refresh our memories. Power functions are things that look like this: a number times your variable to a power. And depending on the power, you know basically the shape of the curve. You know what happens, we talked about it before, if the power is bigger than 1, if the power is between 0 and 1, and if the power is negative. They have very characteristic shapes, just like your BFFs. All right, number 4, now we're going to actually do something here. The volume of a gas varies inversely as the pressure. Okay, so what does inverse variation look like? The equation is K over. So the volume varies inversely as the pressure. There is your setup, because that's what it looks like when you have inverse variation. It's K over. If it were direct variation, it would be K times. Okay? All right, there's the equation. Okay. The volume is 9.2 when the pressure is 163. Then find the volume when the pressure is 74.1. Any thoughts on that? What am I going to do here? It's easy. What can I do with this equation right here? I can figure out what K is, and then once I know what K is, can I put it right there?
Yeah.
And then do the division and have the answer to the question. So, what's K? 9.2 times 163. So K is 1,499.6. And then I'll take that K and put it right here. So the answer is that divided by 74.1. So did you get 20.24? Everybody, is that okay with everybody? The weight of a football player varies directly as his shoe size. So weight varies directly as shoe size. Would you agree with that equation? That one's K times because it's direct. Joe weighs 182 pounds and wears size 11 and a half. John wears size 13. How much does he weigh? This is kind of the same thing. I'm going to solve this for K. So 182 divided by 11 and a half. So K is 15.83 more or less. And then times 13. So Joe weighs 205.74. By the way, if things vary directly, I think we talked about yesterday, is proportional to, is kind of the same vocabulary, maybe that was a different class. But if they vary directly, you could also solve this problem by setting up a proportion. 182 over 11.5 equals W over 13. That would, you could also solve it that way.
I got 205.79.
Oh, maybe I copied it. Oh, no, I know what happened. I didn't use this number. I actually used the thing left over in my calculator, so I have no round off. You have a little bit of round off error in there. Okay, so if it varies correctly, you can also set up a proportion if that's easier, or maybe it's not easier, I don't know. But you can always set up a proportion if they vary directly. Okay? Well, my friends, that finishes 2.2. So why don't we have that due on Friday? When did I have 2.1 due? I don't have it.
Thursday.
Oh, I have it right there. Okay, yeah. All right, so that works out. 2.2 will be due on Friday. All right, now we're going to talk about some really cool stuff. So get your calculator out. We're going to be doing a little exploring on our calculator. But first, I want to remind you of something you already know very well. You want to talk about the end behavior. We're going to be doing some sketching, and we want to know what the ends of the pictures are going to look like. So we have even degree polynomials and we have odd degree polynomials. So even degrees are things like y equals x squared, x to the fourth, x to the sixth. Odd is y equals x cubed, x to the fifth, x to the seventh, and so on. Now, these things are going to have different shapes, but they're going to have one thing always in common. All of these are going to have one thing in common. They are going to end, the ends of the pictures, when you draw the arrows at the end of the pictures, these arrows are always going to be pointing the same way if it's an even polynomial. So I want you to think about your BFFs. What does x squared, that's even, x squared, what shape is that? Parabola. And parabolas start up and end up. Any even degree polynomial is gonna have an arrow shooting up here and an arrow shooting up here, and we don't know what's going on in the middle. All kinds of craziness could be going on in the middle, but it's going to end that way if it's even. Now, think about x cubed. How does x cubed behave? Doesn't it start down here and end up here? So any odd polynomial is going to have an arrow pointing down here on this side and then ending up here, and all kinds of stuff in the middle, but that's going to be its behavior. So if it's x to the 5th, that's what it's going to look like. If it's x to the 15th, that's what it's going to look like. Okay?
Could the left arrow be up and the right arrow be down?
Well, what turns the picture upside down? Got to have a negative coefficient in front of it. And then your parabola isn't like this, your parabola is like this, right? But absolutely, if your problem has a negative coefficient. All right, so now we're going to examine this on the calculator. So what I would like for you to do is go to your window and set your x's at -5 and 5, and your y's at -10 and 10. And then type in the equation with the parentheses and all, just like we did with our box problem. Now, first of all, let's make some observations about what you saw. Did you see classic odd behavior? Does it start down here, do some stuff, and end up there?
Yeah.
Yep. Where does it cross the x-axis? Can you tell? Where does it look like it crosses the x-axis? At -3, -1, and 2? Look at your problem. Is that coincidence, do you think? No. So if you're, in a minute, we're going to be graphing these on our own. When we graph it, our x-intercepts, or the points on the x-axis here, are going to come straight from the factors in our problem. Right? Okay. Let's graph the next one. So take out that equation and put in the next equation. Now that one goes off my screen a little high, but I don't really care about that. What I notice is what? What's different about this one? Well, it crosses the x-axis twice, and how does it behave at that second place it crosses? What does it do? It bounces. It bounces. So this one looks like this. Now, is it still the classic cube behavior? Start down and end up? Because it's 3 x's, it's x cubed. Why do you think it bounces there? What point is that? Isn't that 2, 0? What's special about that factor in the problem?
Square.
And how do squared things behave? They're parabolas, aren't they? Aren't squared things parabolas? Now this isn't exactly a parabola, but it's got parabola-ish features, right? Kind of like a parabola. That's what happens when you square a factor. So in a minute, you're going to be graphing these on your own. If you have a squared factor, it's going to bounce. I like that word. It's going to bounce at that point. Okay? Notice this one didn't bounce because that factor wasn't squared. All right, let's graph the last one. Now it's still a cube. Does it start down and end up like you would expect? But it only crosses the x-axis one place. right? And what's different about the way it crosses? It didn't cross the same way this crossed. What's different about that one? Doesn't it do what a cube does? Doesn't it, think of your BFFs, doesn't it kind of squiggle through like that? When you have a cubed factor, it crosses through, but it doesn't just zip through like this does. It takes its time and squiggles through. So squared factors bounce, cubed factors squiggle. And regular factors just zip right through. All right, so now we're ready. Put the calculator away. Now we're gonna graph them all by ourselves. So when you go home tonight and mom and dad say, what did you learn in school today? You can say, I can sketch polynomials without my calculator. They will be so impressed. All right, so here we go. What's the first thing you're gonna do? You sit down here, you got this problem in front of you. What's the first thing you might wanna do? Okay, so the x-intercepts are gonna be where? -3 and +2 and -1. Notice I always label my intercepts. Now, you're gonna connect all these dots, some kind of wavy line. So you're gonna start up here, we're gonna start down here. Right? How do we make that determination? What do we have to know about our equation? Natalie? I don't know how many x's I've got. Is it even or odd degree? So if you FOILed all that out, you never will want to do that, but if you did FOIL all that out, you would have x to what power? 4. 4th is even. Even is a parabola shape, so up. So we're starting up here, coming down to this point. Okay, so it shoots up. So over here it's going to be going up too. Now, what happens when it hits this point? You have 3 choices. You're going to zip right through, you're going to bounce off, or you're going to squiggle your way through. That depends on this power right here, right? Because that came from here. Well, it doesn't have a power, it's 1. So what does that mean graphically? It goes right through. Now this is a polynomial function, they are continuous. So these dots have to be connected. So it's gonna go down and at some point come back up. We don't know how far down it goes, that's a calculus problem. We're not concerned about that. Just take it down and bring it up. Then decide, what are you gonna do when it hits that point? That one came from here, guys. Pay attention to the factor that it came from. Didn't that come from there? So what's it gonna do? Bounce off. Come back down, I don't know how far, and connect to that. What's it do when it hits that one? Right back through. Yep, because it came from here. So there is your picture. Now again, I have no idea how low these are, and I'm not concerned about that. But just for fun, let's sketch this on our calculator and see how close we came. We'll have the right shape. We just won't have the right height and all that. You do okay? I think we did great. sketching by hand. So does anybody else get a Coke at lunch? I think it's
I've
not
heard they
carbonated.
like, out of the carbonation.
Mm-hmm. Yuck. All right, where are my x-intercepts? Ooh, what do I do with this? 0, very good. If you have an x sitting there, not added or subtracted anything, it's just 0. And then you're gonna have one at -2 and one at 3. So did everybody agree those are my x-intercepts? How many x's do I have altogether? So this is an x to the 6th. Now, under normal circumstances, an x to the 6th would be up. But, as Peter talked about a minute ago, there's a negative out here. Anytime you put a negative in front of a function, what does that do to that function? It turns it upside down. So instead of being up, it's going to be down, down. So this guy's gonna start down here, and he's gonna end down there, hopefully. All right, here we go. What's he do when he hits the -2? Bounces, it came from there, he bounces. He's gonna come up and hit the 0. What's he do when he hits the 0? Just goes through. Now I gotta prepare for this one, because what's he gonna do when he comes through here? He's gonna squiggle, so I need to get a squiggle going. And there we go. All right, is everybody keeping up okay? Hey, look at the next one, guys. What is going on with the next one? Yeah. Sydney says, we can't do anything with this until it is factored, because the factors give us the x-intercepts, right? So if we don't have factors, we don't have the x-intercepts. So what do you think about this? What do you notice maybe about it?
Can we factor by grouping?
Can we factor by grouping? I think we can, because if we take an x squared out of the first two and a -4 out of the last two, I think the magic has happened. We have a common factor. And what about this x squared minus 4 that we have left here? What's that? Difference of squares. So +2 minus 2. All right, take a minute, look that over if you're not sure about factoring by grouping. Took an x squared out of the first two and a -4 out of the second two. There's our common factor, there's the leftovers. Good? All right, graph it. Graph it. All by your little selfies. You can do it. Did you end up with something like that? It's a cubic function, x cubed, positive, starts down, ends up, no bouncing or squiggling. Is that okay with everybody? Now what about the next one? What do you think about this? Can we factor it?
Take out a 2.
We could take out a -2. -9, -1, or -9, -1, which means that my intercepts are at 1 and 9. Isn't this just a parabola? Opening down. Now, I said earlier that how high it goes is a calculus problem, but not for this one, because isn't this point the vertex? And good review here, how do we find the vertex of a parabola? This is your equation right here. What? -b over 2a, 5. So this is 5 comma something. And how would I find the something? Plug it back in. So -2 times 5 squared. The only reason we can do this, guys, is because it's a parabola. -50 plus 100 minus 18. Did you get 32?
We have to do this like on a test. Like,
Well, we're definitely gonna have to find the vertex of the parabola. So it may not be in a picture like this, because I'm probably not gonna give you a parabola in a graph, because we got much harder ones to look at. But it is, you do need to know how to find the vertex of the parabola. So that's good review, reviewing those steps. Okay. That's also gonna show up in word problems, because we'll need the maximum of something, right? So there we go. All right, next one, E. Let's see, what do you think? Kara, you're back there examining your fingernails. What do you think about E?
I did, what do we call it? Soap, I think? Wait, no, it's not soap, it's, where you do the one, and then the other one with the
Okay,
3.
well, okay, so yes, you're kind of I know where you're thinking. Not in this problem though, because the soap and the little parentheses and the big parentheses, that is when we factor the sum or difference of cubes. Now, we definitely have x cubed, but is minus 36x, is that a cube? No. So what you're thinking of, if we had something like x cubed minus 27,
Okay, so if the other X wasn't there.
and if that were a cube, 36 in the cube. But if it were, so if you had something that looks like this, then yes, we would do exactly what you said. Same, opposite, always positive, or whatever that acronym is. Yes, that's right, but not for this one. This one's much easier than that, actually. What can we do with this? GCF? So we'll pull out an x and be left with x squared minus 36. And then we have the difference of squares. So your objective is to graph, but guys, you have to factor first. If you're gonna do this by hand, you gotta get it factored first. Any bouncing or squiggling or anything like that? No, so it's just a regular old cubic equation. striking fear into your heart. That's why they have stars next to them. We are going to come back in a day or two and do F and G. Right now, we're not really capable of doing F and G based on what we have done together. Because what do you notice about problem F, for example? It does not factor by looping. So we're going to have to come up with some other factoring techniques. And we'll be doing that, but we're going to hold off on those two. So just don't panic. We're going to learn how to do them, and they're not that hard. They just involve some extra things. All right, so let's go to number 3, because we can do number 3. Number 3 says write an equation of the cubic function with root 3, negative root 3, and 6 as zeros. So in other words, I got a picture, and negative root 3, positive root 3, and 6 are the zeros. Your job is to write the equation. So pretend you're starting with this, and you're working backwards to this, and then eventually to this. Well, can we get from here to here pretty easily? What would these factors have been for those two zeros? X plus root 3, X minus root 3, and X minus 6. Okay. Now it says multiply out. That actually is your equation. That's fine. It says multiply it out. So, okay, FOIL, FOIL, FOIL. So let's FOIL these two. So out go first, outside, inside, last. Remember, root 3 times root 3 is 3. Well, isn't that just x squared minus 3? And I'll multiply it times that. So x cubed minus 6x squared minus 3x plus 18. I think there it is, guys. Did I do that too fast for anybody? X-intercepts give the factors. Sometimes we'll multiply out. The next one says do not multiply out, so we won't multiply the next one out. This one said multiply out, so we multiply it out. Now, everybody get this? Answer, I mean? Okay, what I'm curious about is, why does it say write an equation? Why doesn't it say write the equation? Because what?
Multiple.
There's multiple answers to the problem, Amanda. You are right. Now, can somebody explain that to me? How can we have multiple equations that have these x-intercepts? Would this be one such equation? Would that be an equation that had those as intercepts? Mm-hmm. What about this one? Would this be another one that had those? What about this one? Would that be another one? What's controlling that? It's not the factors. The factors give me these 3 dots. So what's changing from the black to the pink to the red? What?
Isn't the answer the root, so it has to be plus or minus?
No. It's not coming from the roots. The roots are giving me these dots, and they aren't changing. The coefficient. Maybe that's what you meant, the coefficient. This number out here in front, whether you put it here or whether it shows up down here, what does that multiplier out in front? Guys, I want you to think about back when we were doing all that crazy graphing. What happened when I put a 2 in front of the function? It stretched it, right? So maybe that's the pink one. What happens when you put a negative in front of the function? it turns it upside down and makes it the red one. So I don't know what that coefficient is. I do know that the basic structure of the equation is this, because that's how I got my x-intercepts. But without them giving me another point, another piece of information, I can't tell you what that coefficient is. So you could put, I got 1 there, you could put 2 there, 5 there, anything you wanted there. That would be an equation that had those roots. All right, number 4, write an equation. A new word. What do you think it means when it says 1 with multiplicity 3? Can't hear you, what? No, it's a good guess though.
Three's the power.
Yeah, it happens 3 times. The root happens 3 times. So x equals 1 happens 3 times, which means the factor x minus 1 is cubed. That's what multiplicity means. It's a multiple root. It happens more than once. And that means its factor has an exponent. Now, x plus 4 is just x plus 4, x minus 3. Here's your polynomial. Now, do you understand where I said don't multiply it out? That would take a long time, wouldn't it? You okay with that? All right, get your calculator back out. If you remember how to do regression, then you're on your own. If you don't remember, then just press the buttons I tell you to press. All right, we're gonna go to Stat, Edit. I have stuff in there, so I'm gonna clear that out. You can type right over it if you want. And then L1 is going to be my x's, and L2 is going to be my y's. And I have to make sure they're lined up right. So I've got my L1s in, 3, 4, 5, 6, and 8. Now the corresponding L2s are -7, -4, -11, 8, and 3. Now the problem stipulates we're going to do quartic regression. So go back into Stat and over to Calc, and then somewhere in the list you'll see quartic regression. So hit that. Some of you have to go down and hit calculate or whatever, it depends on your calculator. But what I need for you to understand is, they give you a whole bunch of numbers and they aren't very nice. At least mine aren't very nice. But at the top, it tells you that your equation is ax to the 4th plus bx cubed plus cx squared plus dx plus e. That's your equation. Then under that, it gives you all the a's, b's, and c's. So it's, I'm going to do some rounding here, -2.21 x to the 4th plus 45.75 x cubed minus 339.79 x squared plus 1075.25 x minus 1231. Did anybody match that, or did I type it in really wrong? Looks good? For real? Awesome. So what you just did was take these random points that they gave you, and you wrote the equation of the quartic function that contains those points. You calculated it. But that equation contains those 5 points that they gave you in the problem. Okay? Not today. We're not quite done getting them all taken. Yeah, I know, we're just flying, aren't we? 2.3 is also, oh wait, I gotta look at 2.3, I wanna make sure there's no articles in there. Before I tell you that's gonna be due, let me look at it real quick. Yeah, you can do it. 2.3 will be due on Friday also. And we're gonna do one long division problem and then I'm gonna stop. We've done a lot of stuff today. We covered a lot, but we're gonna do one long division problem. How many of you remember doing polynomial division last year? Either synthetic division, or long division. Now, nobody in the whole wide world likes long division. Okay? Even me, who pretty much loves math, all things, doesn't like to do long division. But it is necessary in some cases. Look at problem B, 1B. Long division would be necessary there because the thing you're dividing by is an x squared. When the thing you're dividing by, it's called the divisor, is not a plain x, then you're gonna have to use long division, okay? We wouldn't have to with number 1, but for our first practice problem, we're gonna keep it simple. So here's how long division works. There's your division sign. Out here, you're gonna put the thing you're dividing by. Hang with me, we're only gonna do this one problem, I promise. Stay with me. Here's the thing I'm dividing by, the divisor. Here's the dividend. While it isn't absolutely necessary in long division, it is in synthetic division, but not in long. I'm gonna go ahead and put a 0x there. Did you notice that there's no x term in the dividend? This helps me keep things organized, okay? So here's what I'm dividing by my divisor, here's what I'm dividing into my dividend. All right, now I'm ready to start dividing. So I ask myself this question. What do I take times x to get x cubed? X squared. So I like to be organized, so I'm gonna write it here. I don't care where you write it, it doesn't make any difference. I like to keep everything in line. So I'm gonna put x squared up there because x squared times x is x cubed. X squared times x is x cubed. X squared times -1 is -1x squared. So x squared times x gives me my x cubed, but I gotta take x squared times the other thing, so I got -x squared. As with regular division, regular number long division, you're now going to subtract. You gotta subtract it all. So this becomes negative, that becomes positive. These cancel, always will. That's how you did it, that's how you set it up. And now I've got 5x squared. And then I'll bring down my 0x next and start all over. How many times does x go into 5x squared? Or what do I multiply times x to get 5x squared? 5x. So 5x times x is 5x squared. 5x times -1 is -5x. Now I'll subtract. These cancel, always will. So I've got 5x. Bring down my -2. Okay, start all over again. What do I have to take times x to give me 5x. Right? So 5 times x, 5 times -1. Subtract. These cancel, always do. Got a 3 down here, and I'm out of stuff to bring down, right? So what's that? That's my remainder, right? So if I were going to write my answer out here, I'm kind of under the thing here, but I would write plus 3 over x minus 1. Just like if you were dividing by 4, this would represent 3/4. It's the same thing. And there's your answer. Now, 2 questions for you. Is x minus 1 a factor of this polynomial? How do you know? Because it has a remainder. So I want you to think back to those really hard problems. Remember that we skipped? And we couldn't factor by grouping. So what we're going to have to do with those numbers, you guys, is we're going to have to do some division and try to find something that divides in and leaves a remainder of 0. Because that will be a factor, right? So, oh boy, that's going to be some guessing. Okay, so let's see. We've got a lot coming up. So Thursday, you have 1 homework due, and Friday you have 2 homeworks due, right?